We'll get you in here, Tom. And everyone's hopping in already. Man, that was fast. Just jumping from session to session here like crazy.
It's a lot easier when you don't have to pick your butt up and move.
Right, and run from one exhibit hall to the other like you had to do back in the day.
Yeah, and not knowing where I am or where the next thing is or where it says how many people are listening to this session.
So we've got 7 hopping in so far.
So
we'll give people a few minutes.
Yeah, we're going to see if the title of the banana problem is going to be able to hold caramel.
Listen, we have, hey, Tyrone, thanks for jumping in. We've got a lot of people hopping in. I think they're hopping in so fast that the thing can't count it. Because I saw 52 people hopping into the room here. Yeah.
Well,
yeah, big jump.
It's too bad this talk is bullcrap.
Oh, too bad. It was something that you and I made up for the podcast.
This is excellent. I'm ready. I'm ready for the banana problem.
Are you ready? So, hey, Stefan, and let's see, we've got Jay Matlock hopping in. Shout out to you guys. Thank you so much. We should probably, I want to give people just a few more minutes to hop in here. Let's give them at least one more minute, Tom, and then we'll take the leash off and turn you loose. By the way, I love that painting in the background.
I've actually been waiting for someone to comment on the painting.
I have seen the painting personally, and what you can't see is there's a man with an arrow in his neck, right at the main, like the focal point of the painting.
That's right. That man is Harold Hardrada, who was shot dead in 1066, only a few weeks before the Battle of Hastings. And the fact that Harold Godwinson had to drag his sorry butt up to York to beat the tar out of Harold Hardrada, I argue, is the reason why William the Conqueror won the Battle of Hastings.
So this is all beautiful, and that's all well and good, Tom. But I bet Nicholas Hughes that I couldn't get you talking about a historical war battle at the beginning of the session. So Nick, you owe me $10, dude.
Oh man, I've been duped.
Hey, Artem, good to see you. All right, so everybody's jumping in here. Welcome everyone to SaltConf 20, virtually everywhere. We're very excited to have you here. We hope you've been having a fantastic virtual conference. This is definitely a different thing for us here at SaltStack and VMware. We haven't really done this sort of thing before. And I would like to give a plug here really quick before we go. Tom and I host a show, a podcast. We're co-hosts of a podcast called The Hacks, which runs every Tuesday. And we'd like to invite every one of you to check it out. In fact, this is one of our most popular podcasts that we've done. Was the title of it was called The Banana Problem. And it was so popular, in fact, we thought that it would be good for Tom to do another quick presentation on this. And I think people are going to have a lot of questions. So as people are making their way into the session here, I just want to give a quick shout out to Tom Hatch, the creator of Salt, the co-founder of SaltStack, the former CTO of SaltStack, a historical juggernaut, co-host of The Hacks, mother of dragons, and one of my very best friends ever. Ladies and gentlemen, this is Tom Hatch.
That was a pretty fantastic introduction. And you didn't lie and say I'm a champion swordsman.
And he's a champion swordsman.
I'm not a champion swordsman. And I'm not beyond oblivion. David Evans, who is aware of the fact that I used to work for a company called Beyond Oblivion, who fulfilled their name at the end of 2011, is cracking a joke in chat. All right. The time has come to discuss bananas. Bananas are so succulent and delicious. Like Chunga was saying, this is a concept that I would occasionally chuck around the office. And we decided to do a podcast of it. And apparently people thought it was really interesting. And it's been one of our more popular hacks podcasts. I gave a presentation of this on Black Hat, and it was a popular presentation at Black Hat. And so I've started to more thoroughly popularize the banana problem concept. So the banana problem really is all about bananas. So back in the 1950s, there was an outbreak of something called Panama disease. And some of you may have heard, especially from your grandparents, that we used to have a different kind of banana. We used to eat a different kind of banana. And apparently they were sweeter, and they were better tasting, and they were easier to package and ship, which of course we care about very deeply. And it was called the Big Mike banana. But in the 50s, there was an outbreak of Panama disease, which infected the Big Mike banana crop. And all of these bananas were almost genetically identical, which meant that they were incredibly susceptible to Panama disease. And the Big Mike banana is not extinct. Some people will say that it's extinct, but it's still out there. You can still spend like $70 and get a bundle of Big Mike bananas. And I hear they're delicious. I desperately want to get me some Big Mike bananas. But in 1965, they were deemed to no longer be commercially viable, right? Meaning that the efforts that it took to keep Panama disease away from the bananas and the risk and the loss of crops that were being seen on a regular basis because of Panama disease, we gave up the fight. And we said, the disease has won. And for the record, we're putting up a pretty good fight right now against a particular disease. And we should keep fighting it, because most times in history, the vast majority of times in history, when disease comes, humanity has said, I give, because they're so hard to deal with. But we can beat the disease. We can beat the ubiquity. We can beat the problems. And the way that we beat that problem is understanding the banana problem. So in 1965, the Big Mike banana was replaced with the banana that we love now, the Cavendish. There's a lot of people. Big Mike banana, a banana I have never tasted, but someday I will partake of the Big Mike banana. So you're thinking, Tom, why the devil are you starting this presentation talking about a failed banana crop? This doesn't make any sense for tech. The reason I call it the banana problem is because the banana problem exists due to the fact that there's not a whole lot of genetic diversity inside of cash crops. This isn't a problem that's unique to bananas in agriculture. It's a fairly common problem across a number of different crops, because what happens is that farmers come in, they take over some fields and some land and grow completely ubiquitous crops. And if a disease or a problem comes about, those crops die in droves. And so recently, there's been a lot more genetic diversity that's been introduced into crops and into seeds, which allows us to defend against diseases and rampant issues inside of our crops. But the same problem exists in tech. And I would argue that it exists at potentially a larger scale. Because the problem with ubiquity in technology is that we want ubiquity in technology. We want consistency in technology. Me even giving this presentation is almost like me giving an anti-presentation, because I've spent so much of my career pushing the importance of a ubiquitous infrastructure, pushing the importance of being able to have everything running on the same stack, everything running as consistently as possible. But as I still think in.
We may be having some connectivity problems with Tom. Can everybody hear Tom okay?
I can't hear you.
In the chat. You can hear me now. Tom, I think yeah, it looks like we lost you there for a second, Tom. Can you pop back on video? Are you available on video? Yeah, he cut out a bit there, unfortunately. I don't know what the problem was. Let's see if we can get him back. He just does this to build dramatic effect. That's all. To keep us hanging on his every word. Oh, now he's gone. He's like all the way gone. All right, let's give him a few seconds here, guys. Thanks for your patience. I keep telling him, quit using those acers, but he just doesn't listen to me. Let's give him a few. We'll give him a few minutes here. No idea what happened to Tom. He just disappeared. Went into the upside down. So, how are you guys? You good? That's good. I hope you're all having a great. SaltConf so far. Thanks again for taking the time to be in all these sessions and let us be a part of your world here for a little bit. It could be, Conrad. You may be right. It could be the banana problem that is causing this. And that's. It looks like Tom. Are you there? Are you jumping in, Tom? Go ahead and hit the share audio video, and we'll get you back in here and get you going.
Okay, can you hear me now?
Yeah, we got you. Can you turn on your camera? Is that working?
It's not, actually.
Your video is not where. Okay, well there you go. Now you're screen sharing, so it looks like you're going to be okay.
All right. So where did I cut off? How deep into bananas and tech did I get before the epic fail?
Oh man, we're still losing you, buddy.
This isn't good.
No, this is a little bit of a problem. So we lost you right after you said, "Allow me to introduce myself. I'm Tom Hatch." No, totally kidding. Yeah, yeah. A couple of us had the same idea there in the chat. I think if you pick up at this slide here, Tom, if you pick up right here, I think everybody can get the idea.
Okay.
Let's give it a shot here.
Okay, can you hear me now?
Yeah, I think we've got you good. I'm looking at your signal in the screen share here, and it doesn't look the best, but that's all right. Let's go ahead and try it, ladies and gentlemen. Once again, Tom Hatch.
Okay, well, here we go. So, I've spent my career talking about how the importance of ubiquity inside of the data center is paramount to being able to actually deliver consistent software and consistent data centers. And the problem that we run into from a ubiquity perspective, though, is that it creates very specific liabilities. And those liabilities can turn into major problems if they're not taken care of properly. And so I wanted to spend a few minutes and talk about some of those liabilities that are expressed as the banana problem. And so what I want to start with is vulnerabilities, software vulnerabilities. When you have ubiquitous software and everything in your infrastructure is suddenly vulnerable, presents a very specific challenge. And then if we have ubiquitous bugs, then that causes challenges as well, because you can destroy an entire infrastructure in seconds because of a single hard to find bug. And I've got some stories there. And if we understand the nature of ubiquity, then it makes it a lot easier for us to be able to come back and say that that we're willing to deal with it, that we're willing to accept the existence of ubiquity as a problem and have that as part of the scope of things that we're continually working to address inside of infrastructures. So we've got a lovely picture of what are actually some big Mike bananas. But understanding ubiquity is about understanding liability. When we did our episode on the hacks on this, Chunga kept saying over and over again, well, how do you solve it? How do you solve it? And I kept coming back and trying to say that it's a complicated problem. Sometimes in life, there are problems that are not easily solved. And the best thing to do is accept them and acknowledge them, and then realize that there's a liability that comes with those problems. And so I want to spend a few minutes here and talk about how some of those problems end up becoming manifest. So first, let's talk about software vulnerabilities when it comes to ubiquity. Now, as I dive in, one of the things a lot of people are unaware of is that bananas are actually radioactive. Bananas are emitting a very small amount of radiation, but a lot more radiation than, say, your common fruit or Brazilian beach sand. And so it wasn't very hard to find some radioactive banana pictures. When we have something that is completely ubiquitous throughout infrastructure or throughout really a large-scale deployment of software, then the nature of its ubiquitousness becomes a serious part of the problem associated with the vulnerability. And so that also makes it so that it can be very difficult to track down that vulnerability and deal with that vulnerability. And so the scale and nature of how software is deployed also begins to very heavily define how it needs to be dealt with from a banana problem perspective. And so let's take an example of some software that's extremely well deployed and distributed. And I'm gonna hail back to a particular vulnerability that was called shell shock. Now, the shell shock vulnerability was a really serious issue, not just because the vulnerability was remotely exploitable, but in much larger part due to the ubiquity of Bash and the fact that it was inside Bash that it could be exploited. Another vulnerability that was very critical was actually the Linux open source DNS resolver issue, where the process of resolving a DNS entry over the internet could have been compromised. This is one of those issues that a lot of people didn't pay much attention to. It was quietly and reasonably fixed in the background, and most people were able to update their systems without issue, and we were able to update large data centers without issue to be able to solve this. But it's one of those things where, due to the large scale of its deployment, it became very difficult to track down. And it became very difficult to make sure that all of the many grains of sand, so to speak, were properly cleaned up. And so it's easy to go back and realize that Heartbleed is still an active vulnerability in the wild today, despite the fact that it got so much news, despite the fact that it was such a big deal, and despite the fact that fixes have been available for, I think we're pushing 5 years, it still exists because of how ubiquitous it is. And so when we step back and we look at solving vulnerabilities, there's a number of different angles and tacks that we need to take. One of those big tacks that we need to take when it comes to solving vulnerabilities is understanding how the software that we are deploying is actually being deployed. When we step back and we look at a data center, it's generally much more manageable, but still a problem. We need to be able to have tooling that can actively scan and search into that data center. And we need to have the tooling that can remediate those things in a completely reliable way so that we're able to continuously watch out. Because it amazes me how often old vulnerabilities resurface and come back. It amazes me how often old vulnerabilities are reinstalled fresh. So it actually reminds me, one time, here's a personal vulnerability issue. One time I was installing Windows 98, and it was a little later in the life cycle of Windows 98. I think it was 2002, 2003. I don't remember exactly why I was installing Windows 98, but I was installing it from a Service Pack 1 CD, and halfway through the install, my system got hacked. Because of the ubiquitousness of Windows 98, I couldn't keep that thing connected to the internet for more than about 5 minutes without someone actively hacking my system. I wasn't even done installing the operating system when my desktop computer got hacked and I had to effectively restart that install. But we see this today. We see occasionally someone installing an older vulnerable version of Salt and it being hacked quickly. We see people installing old versions of OpenSSL and then being hacked quickly. And so again, understanding that ubiquitousness is very important for being able to solve these issues, but also understanding that the ubiquitousness of the deployment of the software is important. Because as we go back up that tool chain of vulnerabilities, we have to deal with many factors, and we'll talk about a few more of them later. Another factor is the bus factor. It astonishes me how much of the software that we use today is being maintained by one human being or an extremely underfunded organization relative to the ubiquitousness of the software that's being deployed. When we were going through the acquisition process with VMware, which is an incredibly dangerous thing for me to say in a public presentation, but don't worry, I think I'm safe. One of the scans that they wanted to do was to look at our code and make sure that there were not areas of the code that had only ever been contributed to by less than 3 people. Because that bus factor is so incredibly critical. They wanted to know, are there areas of software that we don't have enough people covering them? And so I've got a couple of stories that happen in open source that illustrate the bus factor. So a number of years ago, the individual who had been maintaining time zone and daylight savings, the time zone and daylight savings grid that was used by all Linux operating systems, passed away. When this individual passed away, and only when he passed away, did we, the rest of the world, realize that we had all been relying on time zone and daylight savings information to just magically appear from one person. Corporations had to scramble overnight to adopt the project and create everything that they needed to absorb the time zone information into a workload so that it would be maintained on a regular basis. This is a massive liability that we run into with open source that we need to be very aware of, because the maintainership of large portions of open source software is an incredibly important task for us to execute on a regular basis. But this bus factor doesn't just exist when we're looking at the maintainership of open source software. It exists for the maintainership of proprietary software. In a presentation that I gave earlier today, I talked about the fact that developers are now reporting that they have to maintain or are given maintainership over sometimes as much as 100 times as much code as they were maintaining only a decade ago. The bus factor problem that we're running into today is very, very real. And we need to reassess how it's being managed, because the level and the sheer volume of code that is out there is staggering compared to just a few years ago. And the way that I'd like to put it is that for me to give these presentations, despite my camera not working and I'm having some kind of connectivity issues, I have, of course, put my laptop on top of a bunch of books, right, to elevate my built-in webcam to be able to deliver presentations. The book on the top of my stack is titled Linux Core Kernel Commentary. And this book contains the entirety of the Linux source code for, I think, Linux version 2.0. And it's a book, right? It's on my desk, and it's got all the code in the kernel, and it's a book, okay? And with commentary. If I were to try and print the Linux kernel source code today, you could not put it in a book. It is so much bigger than what could be reasonably printed. And so what happens is that when we have such higher volumes of code, it becomes so much more difficult to deal with the code that's out there. And significantly larger volumes of the code is stuff that just works and nobody is ever looking at. And this is something that is a real problem that isn't going to go away. It's only going to get worse. But it's also something that we need to be actively considering as to how this sort of code is going to be maintained in the long run. Because we've built technology in such a way that outstrips the human capacity to keep up with it. And this is another concept that I think is really important that lends itself to the overall banana problem. And that is that we build software as fast as we can to get product out the door. The number one motivation for building software, whether we're in a startup, a major corporation, or just someone in their basement trying to make something happen, the motivation is just that, to make something happen. The motivation when you sit down to write code is very rarely, well, I'm going to spend a lot of time and write an extremely elegant code base that'll be easy to maintain for a long period of time. No, you sit down and say, boy, wouldn't it be nice if XYZ worked? Boy, that'd be great. I'll see if I can put that together. And then the next thing you know, it's being used around the world. As many of us are very well aware, when Linus Torvalds first posted Linux, he said, hey, I wrote a kernel. It's not that big of a deal. It's never going to be big like Minix or GNU. And so we never start with those thoughts in mind. And so when it comes to dealing with the bus factor, again, I think that we need to be aware of it and that we should be rethinking some of the fundamentals of how we write software with that long-term maintenance in mind. Another thing that I want to point out that I've got a bullet on here is what happened to OpenSSH a few years ago. OpenSSH is one of the most widely used pieces of software in existence, and it's not going away. And a few years ago, the guys working on OpenSSH published some messages saying, hey, we're going to have to shut down our servers because we don't have enough money to keep them running. And in a world where we invest hundreds of millions of dollars in critical software that runs on top of OpenSSH, how much money would you expect them to need? They were asking for $5,000. $5,000. They weren't asking for a lot of money to keep the shop running. They needed more over the long run, but still it was in the tens of thousands of dollars. It wasn't a significant investment for them to be able to keep what is one of the largest and most widely used pieces of software available up and running. But we're running those sorts of liabilities in the wild, and we should be aware of them. All right. So how do we deal with the banana, this emerging problem? And I say emerging only because that first thing that I've got there is what's emerging. The problem of ubiquity inside of technology is not new, and the liabilities associated with it are not new. And then there are people out there who understand and address this problem. But the first thing that we have to do is accept its existence and realize that the ubiquitousness of technology is something that really permeates all of us in a really big way. That when we go through and we create the list of all of the open source projects that our piece of software depend on, that when we go through and we scan the vast amounts of software which is installed inside of data centers and come back and look at those lists, it's important for us to understand that lurking in those lists are many weak links in the chain. And many of those weak links, again, are ubiquitous. And we need to be aware of that. So first we need to accept that the banana problem is real. The next thing that we need to do is assess the areas where ubiquity inside of our deployments, infrastructure, and software are real problems. Because when we're willing to assess these real problems, it becomes a lot easier for us to pin them down, understand them, and learn how to address them. Find out where our liabilities are, and come up with an actual game plan. So assessing these problems really ends up meaning that we sit down and look at our infrastructure and say, what are the areas where I've got the same software that's in a critical location spread across my infrastructure? And how do I make sure that I can manage that software? What does it look like when my live production systems have a banana problem? This is something that we're ignoring more and more in infrastructure, because dealing with the scale of these infrastructures is not only very difficult, but when we look at things especially from an immutable infrastructure perspective, it can be a bigger problem than it was in the past. Because when we look at it from an immutable infrastructure perspective, we're oftentimes not actively scanning what's really out in the wild. We put it in the wild and we say, everything's going to get replaced. It's immutable. But I'm astonished at how many containers I run into in infrastructures, large and small, that have been deployed and happily running for years and happily recycling themselves. And the containers, the images themselves are years old. It was not too long ago that I believe it was Alpine Linux, but I'm not going to say this for certainty, but it was not too long ago that one of the most widely used Linux distributions for containers was shown to actually have a flat-out back door that somebody had been able to sneak in. And those images are almost certainly still wandering around. It's so easy to go to a container registry and just register some images that someone's going to find useful and load it up with vulnerabilities. Excuse me. And so being able to scan these systems in the wild becomes important when we are able to step back and assess what is it that this surface area looks like. And then finally, we have to figure out how to attack the problem. Because again, it's really easy for us to come back and say, oh, well, we have a ubiquitousness problem, but it's another thing to be willing to attack it. And so if we can make it so that a plan comes together, then it begins to work. And we can overcome the banana problem. Not a problem that I think is going to go away, because the benefits of the process that create the problem are in and of themselves deeply valuable. So how do we attack the banana problem? And it really boils down to being able to figure out these major two areas, which is, do I have sufficient visibility into my infrastructure? And that can be very hard today because our infrastructures grow so rapidly and are so distributed across clouds and distributed across infrastructures and people and components. And so we have the problem of being able to deal with not only the ubiquitous nature of the software, but also the ridiculous level of sprawl that we're dealing with today when it comes to containers. One of my favorite things that a SaltStack customer came back and said to me was, I used to have a team of 5 engineers deploy and manage 5 applications. And now because of Salt, that team of 5 engineers manages 50 applications, and we feel like we have bandwidth for more. When we manage larger numbers of applications, again, our core motivation is delivery first, maintenance second. And we see this so heavily in the industry that we have tools that are really good at deploying on day 0, but just don't keep up on day 2. And this also goes back into some of the main reasons why I built Salt the way that I did, is because I wanted a system that's going to maintain your infrastructure on day 0, day 1, and day 2, and maintain your infrastructure into the future, instead of saying, oh, I've deployed it and I can wash my hands. The other side of attacking the banana problem is understanding this bus factor and being able to come back and say, we need to occasionally reassess the open source stacks that we're using and make sure that we are delivering sufficient knowledge, capability, and maintenance to the open source stacks that we are using and maintaining. And that knowledge and resources are either distributed by companies, making sure that their team have people who are able to contribute upstream and become familiar with these platforms, but also, and I would say more, but also be able to contribute the resources and target those areas so that we are continually looking for the weak links in the chain. How often is it that the open source project that is driving significant really is just some single individual in a basement? And being aware of that can help us know where to target, where to help, where to bolster, where to look. And so again, we need to see the vulnerabilities. How many systems have this vulnerability? How easy is it for these systems to go missing? What does the footprint of that vulnerability look like? The shape of a vulnerability in an infrastructure can fundamentally change how it can be exploited in a larger scale. It's one thing to be able to say that, yes, I've got a couple of edge systems, but it's another thing to be able to say that if an edge system gets compromised, this other vulnerability is something that's going to allow an attacker to permeate deep into an infrastructure. And so when we find these issues, how is it that we're going to go about resolving them? What's the attack plan? How can we understand the nature of the footprint so that it's easier to quickly look at it and say, oh, normally I wouldn't worry about a really old version of glibc, but I realize that that old version of glibc means that if my internal DNS server gets compromised, that now everything is owned. And we know that DNS is not traditionally the most secure system. I've heard a lot of system administrators, engineers, DevOps professionals, SREs, etc., over the years say that they're amazed how often it comes down to a problem with DNS. So we need to understand the attack plan. How are we going to deal with this? How are we going to make sure the systems are updated? But also, when we have vulnerabilities that look like they're medium vulnerabilities, vulnerabilities that don't necessarily feel like they surface to the top, when they're ubiquitous, they can cause unique and different problems. Because all of a sudden, no matter how you're attacked through the front door, they've got mechanisms to put down roots built into the infrastructure from a lot of these medium vulnerability issues. And so if they're ubiquitous, they present a larger and more unique threat. So this is SaltConf. So I get to plug my crap. And so I am going to talk a little bit about how SaltStack SecOps in particular was made to fight the bananas. When we come back and we look at vulnerabilities, we have these issues heavily in mind from a SaltStack perspective. We want to be able to look at the system, and we want to be able to assess the system so that we can come back and say, these vulnerabilities on this system are effective in highly specific ways relative to how the infrastructure is deployed. When we come back and we look at vulnerabilities from a SaltStack SecOps perspective, we're also beginning to look at vulnerabilities with respect to how they permeate into the system itself that has those vulnerabilities. So that we can come back and say things like, this specific vulnerability is affecting all of these multiple running services. And therefore, your attack vector is significantly changed. It's significantly broader than what was assumed before. And then, of course, we need to be able to scan quickly and immediately. The people in this conference are probably aware of the fact that SALT is made to ask questions of infrastructure at breakneck speeds. And that really was its first core and primary use, was to be able to ask the infrastructure a question and get an answer. When we're able to ask the infrastructure a question and get an immediate answer, it means that the overhead that we have for these sorts of searches and these sorts of assessments goes down dramatically. And that's really a beautiful thing, because it means that we can ask our infrastructure questions really whenever we want without having to have invasive and difficult scans. And then finally, coming back and attaching that power into a vulnerability database was really a big deal for us. And so the last thing that I want to cover really quick is a few things about avoiding the bus. And that we need to avoid the bus factor at home and be very aware of how that banana problem exists inside of our own organizations, so that we are responsible enough to regularly make that audit and ask the question of, what parts of my code have serious bus factor issues? And how ubiquitous is the code that does have major bus factor issues? And is it ubiquitous because it's ubiquitous and it's everywhere? Or is it ubiquitous because even though it's running on only a few systems, it's so heavily dependent upon by a larger group of systems, so that we're willing to run up the chain to understand? When we look at open source and look at the bus factors, the ubiquitousness can be so much more severe. But it's very, again, worthwhile for us to assess what's going on in open source so that we're able to come back and say, which of these open source projects do I heavily rely on that are not being responsibly maintained? And then we can share that, we can solve that problem by spreading the love. And we can salt the banana. Because that way we can know the banana, we can embrace the banana, and we can salt the banana and say, we do have tools that can begin to help certain aspects of these problems. We do have tools that we can use to bolster the liabilities that we have. But we need to pay attention to problems. It's so easy for us to look at a problem and hate the problem and panic and say, how are we going to solve the problem? Instead of so often understanding that the best way to solve a problem is to embrace it, is to say, I don't think this problem's going away. And since it's not going away, I need to accept the things that are creating it. And accept why the things that are creating that problem aren't going to go away. And only then, after you embrace the banana, are you going to be able to understand how to deal with that, with the ubiquitousness of the problem. And so really what I end with on this presentation isn't just stepping back and saying, hey, we need to be aware of ubiquitous software inside of technology, but also saying that when we have a problem that can't be solved, it's important for us to embrace the problem, regardless of whether it's in technology or politics or whatever, and ask the question of, where did this come from? Why is this a problem? Are there roots to this tree that we can hack on? And then we can begin to solve that problem in a deep and meaningful way so that we can move forward with our lives in a deep and positive way to actually resolve these complicated issues. Because as the global infrastructure, the global code base, and the global economy continues to get more complicated, it's going to be harder for us to solve problems, and we can't solve them with knee-jerk reactions like we so often try to. We have to step back and take calm and wise approaches to solving these problems because of the ubiquitousness that they present, because of the scale at which problems exist today. All right, that's my presentation on the banana problem. I'm sorry that my camera died halfway through. You can't have a virtual conference without some bull crap happen.
That's actually very true, ladies and gentlemen. I know that we can't see and hear you for the most part, but I still think it's appropriate to give this man Tom Hatch a big round of applause. Just the same. Hey, Tom, thanks a lot. I know that you were in all sorts of disarray there, and you still managed to provide an outstanding presentation, and I think it speaks volumes as to your professionalism and your skill with bananas, might I add. So, listen, we do have some time here while Tom is sitting in the dark at his house to maybe answer some questions. Have Tom answer some questions about the banana problem. There's a couple of ways you can do this. First of all, you can always type them in the chat, and I'll relay them for you and give you a shout out. Or you've got a screen there that's it's a green button that says share audio and video, and all you have to do is hit that button. I see your request, I approve it, and then you can pop on the screen with us here and chat with Tom and ask away if you'd like. So with that, I'll open up the floor for any questions if anybody has any.
Okay, and while that happens, I'm going to refresh, so I'll be back in a second.
Hopefully, okay, yeah, no problem. We'll give Tom a little bit of time to refresh. And I want to give you guys a reminder too. As soon as this presentation is over with, the networking and virtual booths will be open. Really simple to get your hands on some pretty good contacts simply by going to the virtual booths. So there's a tab over on your on the left hand side of your screen, and then there's also the meet other attendees thing. We called these originally, we called them tables, where people could sit down and it was almost like a speed dating thing, but we felt that was a little bit too awkward. So, hey, you're back. Look at that.
Yeah.
And you opened the doors.
Actually, on my list of potential problems was overheating, because it was getting a little warm in here, so I opened the doors.
That office is insanely hot. That's no joke. I can vouch for that. It's nuts. Okay, so does anyone have any questions now that Tom is back? No.
This is your chance. Ask me anything. It doesn't have to be banana related. I'm really sorry if you're really bored by my banana presentation.
It was not boring at all. I think, in fact, if anything, I think it was very thorough. What's that? What are you pointing to? What are you saying?
It was Chunga's idea.
Actually, I think it may have been my idea. Come to think of it. Yeah, Jordan Ritz just commented, "Wow, Tom even invites an AMA."
Yeah,
something that you're not to hate is the AMAs.
Well, I've only got a few minutes.
Yeah, for sure.
Earlier today, Dirk. So am I going to be able to get to return to the basement and code again?
It's a great question.
I really want to. So we've talked a lot about pop and item, and I haven't been able to write code for a few months. And that really is becoming a goal. Is that right now the integration with VMware is pretty demanding. the whole acquisition process, if you haven't gone through having a business acquired, it's terribly invasive on your time. That I'll be able to get back to writing some code, because I've actually got quite a lot more that I want to build.
And you know what,
and a lot more
Tom,
that I've got from a pop perspective that I'm really excited.
Well, I've got to say, we're still having some minor connectivity issues, but when VMware acquired SaltStack, that was the first thing you said to me. In fact, I think you may have actually been at my studio when that all went down, and you said, "I'm finally going to get a chance to code more. I'm finally going to get a chance to just sit and do code all day." Because for those of you who don't know, Pop, Item, Umbra, and Heist, these are some of the sexiest products I've seen since I've been in this industry. These are very cool, very pluggable, different programs that work in concert so well together.
Yeah, I miss writing code. I love it. It makes me happy.
Yeah.
And sitting through acquisition evaluation meetings does not make me happy.
It's all over. It's all over, Tom. We got to get you into some therapy over that, dude. Seriously. All right. Well, listen, if there are no more questions, is it Stefan or is it Stefan? I'm not sure. Where do you think SaltStack will have the highest impact at VMware?
So I don't know, to be honest. We're coming into the VRA group first, but there are a lot of groups that want to use SaltStack and integrate it into their products. And one of the things that I've certainly learned is that initial intent and reality are very, very different things. It's very easy for us to wake up and strive towards a specific goal. So actually, I'll throw more philosophy at you because I'm a boring philosopher. It's more important than to work hard and still to work towards goals than it is to accomplish those goals. Because if you work hard and build a lot, then you're going to be able to permeate into many different aspects of life. And new opportunities are going to open up and new doors are going to open up. And so I have no idea where SaltStack's highest impact will be at VMware. I hope that it's somewhere that I don't expect, because that means that we will have had high impacts in other areas, that we would have been successful in other areas. And so it's all about pushing hard, learning as much as we can about VMware ourselves and what we can do with Salt, especially as we move forward.
One thing I can say for sure is that you're going to see an awful lot of Salt implement. It's going to become SaltStack Config is what it's going to be called, and Salt Open will remain Salt Open, but you're going to see an awful lot of Salt with the cloud, with VM Cloud and vRealize, and with Carbon Black. You're going to see a lot, and that will happen right off the bat, as I understand it.
Yep, as I hope so. We'll get as deep as we can, and hopefully I'm surprised. And there's a corner that just does better than everywhere else.
Yeah, there's a follow-up question here, Tom. It says, and will the OSS piece of SaltStack be kept and even broadened?
Yes. So I actually had a wonderful presentation this morning with Dirk, the chief open source operator at VMware. And we talked very heavily about why we value open source, and not just why VMware values open source, but why open source is fundamentally valuable. I'm really excited at the fact that VMware is allowing me to go back to my roots more and be more involved in open source and more involved in being able to drive the open source software forward. And so again, that's something that I'm incredibly excited about, and something that I'm really excited that we're going to be able to double down on. And so you're going to see more investment in open source moving forward, and more investment in Salt. And so we are planning on broadening what we're doing from an open source perspective and continuing to work hard on Salt. Rob Hilberding is asking, we need to keep the Saltines. We haven't actually had a Saltines band for a while.
I'm auditioning.
Play, And I think that we're actually missing our lead singer now. So I might try out for the Saltines.
Oh, I think you should. I've actually spoken with Jeff Blair, who is and Shane, two members of the Saltines, and they do want to keep the Saltines together. But yeah, they've got to figure out who's going to be their lead singer. They may have to switch
Yeah,
instruments and add a guitar player or something like that. I'm hoping.
yeah, yeah. For those of you who are unaware, the Saltines is SaltStack's band. Um, and despite the fact that I had a brain tumor and my left vocal cord is paralyzed, uh, I used to do some professional vocals a very long time ago. Uh,
It's
and I
it's all
love
polka music though. It's all polka music he sings.
it's not all polka music. No, I like many kinds of music.
A lot of people don't know this. Tom can sing, but he can't sing unless it's in German. So that's the X factor.
Mein Deutsch ist nicht gut.
All right, guys. Listen, if there's no more questions, I want to say a very heartfelt thank you to all of you for attending. Everyone at SaltStack, Tom included, has worked long hours to make this day possible, and we are honored with your presence. And we hope it was informative. We hope you had a good time. And we will make all of these sessions available to you, and we'll make them available real soon. So thanks again. The virtual booths and the networking sessions are still going to be available until 6 o'clock Mountain Time. So we still have about another hour and a half where you can go make some more contacts, and you can rub elbows with Tom, and who knows, maybe audition for the Saltines. You never know. Thanks to all you guys. Shout out to Casey and to John and Brooke and Christian and boy, there's a lot of you in here. Holy cow! So thanks to all of you guys. Shout out, and we'll see you in the virtual booths and the networking sessions. Thank you, Tom. Well done, sir. And listen to the hacks.
That's right. Listen to the hacks.
All right, you guys. We'll see you.